The screen is visible.
Yes,
Yes,
sir.
sir.
So in my last class, I talk about the arrays function argument, right? So actually, this thing will be more clear when we will discuss pointer. Okay. So actually, when we are passing array as an argument to a functions, in fact, we are passing the base address to the functions.
Hello.
Yes. Yes. Anybody is having any issue? Anyone having issue? So using normal array, so as we have already written one functions, I think bubble sort, right? Uh, so bubble sort, what you can do, you can pass the array as an argument to the bubble sort function, which will sort the array and return to you. Maybe let me check whether I discuss the bubble sort program. Mhm. It is not there. It is there. See. A bubble sort is there. Okay. Yeah. You can see the bubble sort program here. Uh, is this visible to everyone?
Yes, sir.
Yes, sir.
What I am doing here, first I am entering an array, length of the array, then declaring the array, then with length n, then I enter the array, and then this is how you can enter the array. Then you print the unsorted array here. Okay, then call the bubble sort function. You can see here I am passing the array as an argument to the function bubble. Okay, A is the name of the array. That is the argument. Then I am printing the sorted array. Okay, fine. So first printing the unsorted array, then calling the bubble sort function, then printing the sorted array. So this is the bubble sort functions which I discussed in my last class. You can see here. So I am taking array as an argument to the functions. Then length of the array n, and here doing the swapping as when required, and stopping criteria using plug. Okay, so finally the array is sorted. So you can see an example here. The length of the array is, let's say, 5, and you can enter a unsorted array like 34, 26, 50, 11, 19, like this. And yeah, this is the unsorted array 34, 26, 50, 11, 19, and the sorted array is 11, 19, 26, 34, 50. Okay, so is that clear? I think I discussed the functions in my last class already. This is an example of how you can pass arrays and argument to a functions. Okay, so similarly, any doubt here? Or shall I move? So two for loop are required. You can see here. Outer loop for the number of iteration, inner loop for continuous swapping of elements from bottom to top. Okay, and this is the swap function you can see here. So that's clear. Yeah, I think I am visible. Okay. So now, if I'll see another example, let me take another example. Bubble sort you have seen. Then, yeah, how to in an array. So here I have written functions, binary search and search. Yeah, first discuss the linear search.
Yes, sir.
So here you can see I have to call function. So first I ask to enter the length of the array, declare with that. Then I call the function enter. Can you see enter functions? Okay. So it's array. Call is thing that the passing the even inside the function you are entering the outside. Okay. Main function values of array are visible even though enter function is different. Inside the entering the value, but it is visible outside. Is that clear? So here I am calling enter functions. Inside the enter function, you enter the values of a. Can you see here? And that is visible here. Okay, to the main. Then similarly, I am calling the print functions to print the values. You can see print functions take the array and print the values. Then I am calling the linear search. Enter the search element, then calling the function linear search. Linear search means search an element x in an array A of length n. Okay, search an element x in an array A of length n. So what happened basically here in case of linear search? Linear search. So you have an array, right? So value may be anything 17, 11, 19, 25, 10, 16, like this. So here, this is the array A. Okay, array A means A0. This is A1. This is A2, A3, A4, and A5. Clear? N equal to 6 here. Total 6 number will be. Now let's say I am entering x equal to 25. I want to search 25. Search x equal to 25. Search means it returns the index of the element. So 25 is present as value A3. So the function should return 3 in this case. Let's say I am calling once again the function with x equal to, let's say, 15. 15 is not available, so it should return -1. This is search 17. It should return 0. It returns the index if the element is available, return -1 if the element is not available. Is that clear, search function?
Yes, sir.
Yes, sir.
And how it search? So first, this is x. X is compared with A0. Compared with A0, whether it is equal to A0 or not. If it is not equal, then compare with A1. If it is not equal, compare with A2 and so on. Linearly, one by one comparison will be done. So in the first case, A0 does not match, A1 does not match, A2 does not match, A3 match, so return 3. Is that clear? So you can see here, this is the linear search. Yeah. Look at here, the functions. Okay. Is this clear now?
Yes, sir.
Okay. Fine. So now another search you can do. So how many comparison in the OST case? This is OST case. In the OST case, you have to do n comparisons, right? So that's why the time complexity is order of n here. Okay. So to reduce this time complexity, you can go for another search algorithm, which is again very popular. That is called binary search. Okay. As the linear search is very costly, can go for binary search. But binary search is applicable only for sorted array. If the array is sorted, then only you can apply the binary search. Is that clear? So in this example, you cannot apply binary search because here the elements are not sorted. Okay. Either ascending or descending does not matter, but it should be sorted. So for example, Riddhi Agrawal, I think your mic is on. Okay. Okay. So applicable only for sorted array, right? So for example, if you have a sorted array 10, 12, 13, 20, 27, 30, like this. So here you can apply the binary search, which is faster as compared to the linear search. So in this case, what we will do, we have the data. We have the data of what we know that elements are in sorted order. So we do what, instead of comparing the elements one by one from the beginning, I will directly compare the values of x, search x, search x with the middle element. So here start index is 0, end index is 5. So mid index is what? 0 plus 5 by 2. That is equal to 2. So this is your mid index equal to 2. So I'll directly compare x with the middle value. Then how many possibility are there? Can anyone tell me? Either it will x match with the middle index element, either x match with the middle index element, or x is smaller than the middle index element, or x is greater than the middle index element. Am I right? Please
Yes,
respond.
sir.
So
Yes, sir.
if x is greater than this middle 13, then I will search towards right. If x is smaller than 13, then I will search towards left. Basically, I am dividing the search space by 2. Okay, I am dividing the search space by 2. So, and that process continues. So, once you come here, let's say you know that x is greater than 13, then your start index will be 3, end index will be 5. So, mid index will be equal to 4, and so on. When you reach to a single element, you compare it. If it does not match, exit. Bubble start. So, very small compared to order. So this are very different, right? If n equal to 1000 here, so here you need to do 1000 comparisons. Comparisons. Is it clear?
Yes.
Okay. So the required is the array must be sorted. Then you can go for binary. Okay. So recursion I discussed, right? Recursion functions. Array functions same. Where is recursion? You define functions. Recursion. No, I didn't discuss. Let me discuss recursion here. Yeah. So yeah. So the binary search first. Linear search. Binary search.
Sir, can you please share this program with us, that binary and linear search programs?
Yeah, I'll share everything. I'm putting it in a folder, right? You can see this folder. Everything is there. Whatever I discuss in your class.
Okay, sir. Thank you, sir.
Okay, I'll share it. Look at this linear search. Linear search I did. Non-recursive binary search. see here program. So what are the input? Input is the sorted array A, then size array N, and the search element X. What I'm doing, you can see start and it's containing it at 0, and it is n minus 1. So if n is the length of the array, then and it should be n minus 1. And the exit criteria of the loop is start index is greater than end index. As the start index is less equal to end index, that means you have at least one limit. This condition is satisfied. Start exceed end to come out. Always start is increased and end is decreased. So definitely a time will come when start exceed end. You start every time you in each iteration you are increasing the start value, increasing the end value. So it can come when start exceed, that is the criteria. But if your start is less than equal to end, then you consider the mid index. Then compare it with mid. If it matches, then return the index mid. If it does not match, check whether x is on left side or right side. If x is on left side, then start will remain same, but end will be equal to mid minus 1. Else x is on right side, sorry, x is on uh, right side, so start end will remain same, start equal to start. Is it clear? Look. If it does not return at all, final return minus 1. Then limit is not. Okay, this is the non-recursive binary search. Okay, look here and tell me in doubt.
So can you please repeat your last statement again?
The exit criteria is start index exceed the end index. That means there is no more element to compare. Okay. So in the beginning, what happened? Start is equal to 0 and equal to n minus 1. Last element. Okay. And we iterate our go on dividing the array by 2 till start is less than equal to n. So how we can divide? Finding the mid index, that is equal to start plus n by 2. Then compare the search element X with the middle element. If it matches, then return the index. And to continue further. If it does not match, either X is on left side or is on right side. If X is less than a mid, that means X present on the left side of the middle value. So in that case, start index remains same, end index will be equal to mid minus 1. Else, X is present on the right side. Right side means end index remains same, but start index equal to mid. Whether start is less than equal to end or not. So continue this process till start X end or return. If match at any time, then it return. If it does not match at all, get from the loop, then finally we take the other element is not and we return minus 1. Okay.
Yes, sir. Thank you.
Okay. So this is non-recursive. Let us go to the recursive binary search. Before going to the recursive binary search, let me discuss what is recursive function. So let me discuss the recursive function or recursion. Recursive function. Recursion means a function which call itself. Function which call itself is called recursive functions. Okay, a function which call itself. For example, let's say one is function. In the definition of function, it call f. Is there one calling one? Okay, so let me take two example and understand. So let's say I want to find out the factorial of number. For example, this example. So you know that n factorial can be written as n minus, sorry, n to n minus 1 factorial. Am I right?
Yes.
Yes.
So that means fact n factorial of n can be written as n into factorial of minus 1. If you are writing the definition of a factorial function, that means you have to recursively call the factorial of n minus 1. Right? So the factorial. So I'm writing the complete function for integer man. You define x equal to 5, let's say, and then call fact of x. Y equal to fact of x. Okay. Y equal to fact of x. Whatever you have. Like this, different zero. So we are done. Till I have not point. You are calling the function factorial of x, which return the factorial. For example, x equal to 5 means you are calling the factorial of 5. So it should return a value fact integer a. So if a equal to 1, so what value should be written? Factor of 1. You tell me.
1.
1.
1. Else return what? A to factor of a minus 1. So this is how you call because of factor. So example in this case, first fact 5 will be called, 5 will call a is not equal 1, so 5 will call fact 4, and fact 4 will call fact 3, fact 3 will call fact 2, fact will call fact 1, fact 1 will return what? It returns 1, then fact 2 will return what? Fact 2 will return 2 into fact 1, that means 2. But I am returning a return value 1, then it return what? 2, it return what? 6, it return what? 20, and finally it return 120. Are you getting it?
Yes, sir.
One example, let's say I am taking, let's say feedback I to discuss, let's say Fibonacci, and that Fibonacci number. Fibonacci number using Gaussian. Print a Fibonacci number using recursion. So you know that f0 equal to, let's say, 0 and f1 equal to 1. First two Fibonacci number you know. Okay, and f n equal to what? F n minus 1 plus f n minus 2. N varies from? Am I right?
Yes, sir.
So